So, first of all, I would like to say hello, sir. Today, I am going to do the presentations on our projects about the introduction to optimizations power method. So, first, we will talk about the brief description of my project. So, power method is strictly power conjugate direction method. It's an algorithm that proposed by the Michael J.D. Powell for finding a local minimum of a function. That function need not be differentiable and no derivative are taken. The method is useful for calculating the local minimums of the continuous but complex function, especially one without an underlying mathematical definition because it is not necessary to take a derivative. So the basic algorithm is simple, but the complexity is in the linear search along the search vector, which can be achieved through difficult mathematical calculation. And the function must be a real value function of a fixed number or real value input. The caller passes in the initial point, and the caller also passes in a set of initialized vectors, search vector set. And second, we're going to talk about the definition of the power method. So power method is the way to minimize the function in multi-dimension, or we can say it a multi-variable optimization without using the database. And the minimum value, the denotation of the minimum value is mean of f of xn, where xn is the point in the hyperdimension n hyperdimension. So to use this method, first we initialize the starting point and let it be x0 and do the bidirectional line search, and all minima found during a bidirectional line search be the set of x1, x2 until xn. And to find the sequence of x, so like x sub n is equal to x sub 0 plus the sigma I starting from 1 to n of alpha I and ai, where alpha is the scalar, that make the direction also ai, the vector ai, be the minimum value, yes. And the exceptional extreme point is found when the minimum of Fn is a convergence, or the bidirectional search is conjugate to get the two vector of bidirectional search is conjugate. So now let's move to the algorithm. So here is my project algorithm. Okay, so here is the example of the algorithm. Below here is the power method, which include the example in each step, and let x0 is the initial point and the starting direction h1 and h2. Okay, so staring at x0, perform a 1D optimization along h1 to find the extremum x1 here, and x1 is equal to x0 plus alpha 1 h1. And starting at x1, perform a 1D optimization along x2 to find the extremum x2. So here, x2 is equal to x1 plus alpha 2 h2. And then define h3 to be in the direction connecting between x0 and x2. And starting from x2, perform a 1D optimization along h3 to find extremum h3 here. And h3 is equal to h2 plus alpha 3 h3. And starting at h3, Perform the 1D optimization along H2 direction, and let's call it H4 to find extremum H4 here, and where H4 is equal to H3 plus alpha for H4. And starting from H4, perform a 1D optimization along H3 direction. Let's call it H5 to find the extremum XY. And XY is equal to X4 plus alpha for H5. And define X8 to direction H3 and H5. Keep repeating the process until you find the conjugate vector AN or the convergence or the minimum of function. But in this case, we see that H6 and H3 are conjugate, so the minimum point will lie on the optimization along H6 starting from X1. Now let's move back to slide. Okay, so let me give the example. Let our function fxy is equal to x minus 2 square plus 2y plus 1 square plus 2 sine 2 pi x sine 2 pi 1. So the initialize, first we set the x0, y0 to 1 and minus 1 as the initialize points. Set the third direction d1 is equal to 1, 0, and d2 is equal to 0, 1. And set the tolerance threshold epsilon for convergence. Iteration 1. Evaluate the function at the current points f x0, y0 equal to s1 minus 1. Update the point along the first third direction x1 equal to x0 plus alpha d1, where alpha is chosen to be a minimized fx0 plus alpha d1 and y0. Update the points along the second third direction y1 equal to y0 plus beta d0, where the beta is chosen to minimize the f of x1 y0 plus beta d2. Update the third direction d1 equal to x1 minus x0, y1 minus y0, and d2 equal to 0, 1. Checks for the convergence. If the f of the x1 y1 minus f of x0 y0 is less than the epsilon, terminate the output minimum point x1 and y1. Otherwise, go to the next iteration and keep repeating this process until you find the differentiate between the function fx1 y1 minus fx0 y0 is less than epsilon. So you can say that the minimum of function is convergent, or you can do this process until you found the third direction is convergent or conjugate to get together. So here are the application of the power method. So in engineering, power method can be applied to various optimization problems where the object function is complex, nonlinear, or lacks analytical derivatives such as design optimization. The power method can be used to optimize the design parameter of engineering system or component. For example, in structural engineering, it can be applied to find the optimal dimension of the structure, the minimize weight while satisfying strength and stability requirements. 2. In engineer, they also apply to process optimization, system celebration. That it means that in engineer system that involve multi-components or sensor, the power method can be used to celebrate the system by finding the optimal setting or adjustment factor for each component to ensure accuracy and reliability operation. 4 is about an image and signal process. And power method also apply to economics. Like they can apply to various optimization problem and economic modeling tasks. And some specific applications include economic modeling, simulation, portfolio optimization, It means that in financial and investment management, the power method can be employed to optimize a portfolio allocation by consider the various assets, their expectation return, risk measurement, and power method can help determine the optimal allocation of investment to maximize return while controlling risk. Optimal taxation and public financial, market equilibrium, and analysis. And power method also apply in medical science. Like it's not commonly applied directly in medical science, but it can be used in certain area of the medical research practice, like drug dosage optimization. It means that they used to optimize the algorithm include variant of the power method that can be utilized to determine the optimal dosage regimen for the medical science by considering the factors such as drug efficacy, toxicity, and patient-specific characteristics. And this method can help identify the dosage that minimize therapeutics benefit while minimizing side effects. It also, in medical science, it also used to optimize the medical and make analysis, experiment design optimization. Like in medical research, optimization techniques can be employed to design experiment effectively by optimizing factors such as sample size, treatment allocation, or time point for data collection. And this method can help maximize the efficiency and informative of the experiment. And last for the medical science is used to optimize the treatment planning in the radiation therapy. Moreover, power method also applies machine learning. Like it's not commonly used optimization algorithm, but however, there are several other optimization algorithms that specifically designed for machine learning tasks such as gradient descent, limit memory, Broyden-Fletcher, Goldfab-Sano, and conjugate gradient. And the last one is about the coordinate descent, that coordinate descent optimize one parameter at time while keeping the other fixed. So here are all for the application of power method, and our present also come to end. So lastly, I would like to say thank you, sir, for your listening, and goodbye, sir.